So in example 2, we will be evaluating piecewise functions. So this time we're going to be solving for different values of x in our piecewise function. So before we dive into our lovely part A of this problem, I just wanted to go over again what our inequality notation means and what our interval notation means. So in the Prezi slide, this is what you saw, which usually with piecewise functions you have inequality notation. But for the people that like interval notation, I just wanted to go over what that meant. So this first interval, the first number in our piecewise function is 5. So the function will equal 5 for the values where x is larger than 0 and less than 13. And they cannot equal 0 and 13 because we don't have a little line underneath of it. So these are all the numbers that fall in between 0 and 13. So when we have our interval notation, remember we use parentheses when it does not equal that value, and we use brackets when it can equal that value. So the first number is our smallest number in the interval, which is 0. And the number on the right hand side is always the largest number in the interval, which in this case is 13. And so the reason why we use a parenthesis is because both of these don't have an equal to symbol. Now the next number in our function, the function will equal the value of 9 when x can equal 13 and is larger than 13 because it's equal to and the symbol means larger than. But it is less than 55. So it cannot equal 55 because we don't have a little line underneath. So let's solve our interval notation. So again, the smallest number in our interval is 13 and the largest number is 55. You always write the smallest number on the left hand side of your interval notation and the largest number on the right hand side. Now the reason why this one has a bracket and this one has a parenthesis is because on the 13 it can equal the 13 because we have that little equal to symbol right there. Alright, and it cannot equal the 55 because it does not have an equal to symbol. So that's kind of why this one has one bracket and one parenthesis. Now the last value in our function, the function will always give you a 6 if x can equal 55 and is larger than 55. X is greater than or equal to 55. Now for this interval notation, the smallest number when we're greater than or equal to 55, the smallest number we can use 55. And since we're all the numbers larger than 55, we are headed in the positive infinity direction. So to infinity and beyond with Buzz Lightyear. It's going to be a blast. Alright, and the reason why we have a bracket right here is because it can equal to 55 because we have that wonderful line underneath our inequality symbol. And then our infinity symbol does not have a bracket because remember you can't really ever equal infinity. You can get really close to infinity but never really equal it. So you can see either of these notations. So whichever one you prefer. Usually with piecewise you see an equality notation, but this means the same thing. So now let's get to solving with our function. So we're going to be evaluating 3 different values of x. So it says evaluate the piecewise function for x equals 5, x equals 20, and x equals 100, which I split them up into 3 separate problems. I numbered them 1, 2, 3, just like I did here. So our first one says we want to know what the function value is when x is 5. So I'm going to be replacing my x with a 5, and we're going to see which value it will give us. Okay, so we're solving for f of 5 because that's the function value when x is 5. So we're going to be solving for f of 5. I just put this 5 in for this 5. So we want to know what the function value will be when x is 5, which when we look for when x is 5, we're going to be looking over here. So we want to see which one of these inequalities a 5 is allowed in. So let's see which one the 5 is allowed in and which one rejects the 5. So like if we look at this last one, it says x is greater than or equal to 55. So if I put a 5 in its place, is 5 greater than or equal to 55? No, it is not. So this one will not work. Now this one, 5, if I put 5 in for an x, 5 is not in between 13 and 55. So that one also fails. So if we look at this first one, if we put a 5 where the x is, 5 is definitely in between 0 and 13. So when x is 5, the function will be 5 because our interval that works is the very first one. So when we're solving for f of 5, the only one that works is this one. So when you guys are solving for values in a piecewise function, you look over here to see which one of these the x is allowed in. Once you determine that, then you pick whichever one fits. So when we solve for f of 5, the only one that worked was this first one, which relates to this 5. So f of 5 would be 5. And that is my answer. Awesome, awesome. Alright, so we're going to do the same thing for this next one. So we want to know what the function value is when x is 20. So I'm going to be basically solving for f of 20. So again, before we figure out what goes there, we go back up here and we say which one of these does 20 fit inside of. So here, if I look at my first interval, it does 20. Is 20 larger than 0? Yeah. But is it less than 13? No. So the first one fails. It super fails. Alright, now this last one, if I put a 20 in there, 20 is not greater than or equal to 55. So that one fails. But if we look at the middle one, if I put a 20 where the x is, 20 is larger than 13, but it is also less than 55. So it works. Yay! So our middle one is going to be our answer. So when x is 20, the function value will be 9. And that would be it for that one. So when f is 20, or when x is 20, and we place that into our function, we get a 9, because that's the number that's associated with this interval. And that would be it for that one. Alright, so we're going to do this one more time, so get pumped up. So our last one, again, we have to see which one does this value work in. So we're solving for the value of the function when x is 100, so we're solving for f of 100. So looking here, the only one where 100 works is this last one, because 100 is definitely greater than or equal to 55. It definitely works. These other two, 100 is not in between 0 and 13, and 100 is not in between 13 and 55. So when x is 100, the function value will be a 6, because that is the one that works. And that would be it for part A. So f of 100 equals 6. Ta-da! That was fun times, you guys. Alright, now, I don't think these problems are hard enough yet. I think we need to step it up a notch. What do you guys think? So let's take a look over here. So basically, you guys, we're going to be doing the same thing. Okay, we just have more than one function to solve at a time. So this one says to find f of 13 plus f of 70 minus f of 1. So we need to find what all these function values are separately, and once we know it all, then are we to substitute them in to where they fall in our expression. Are we ready? I'm totally ready. Let's get going. So let's figure out what f of 13 would be. So if I look here, the only one that 13 lies in, now this one's tricky because this one and this one both have a 13 in it, right here and right here. So we have to figure out which one the 13 is allowed in. Now this one, it says x is less than 13 but cannot equal 13. This one says x is greater than or equal to 13. So it's greater than 13 and equal to 13. So since this one has an equal to symbol and this one does not, that would mean that the one that would work is our middle one. Okay, so we have to be careful. If we have a number that's one of the values in our inequality, we have to pick the one where it equals it, which this little equal to symbol allows us to be equal to 13. So when x is 13, the function will be a 9. Alright, now let's solve for f of 70. So if I look at my three intervals, the only one where 70 fits is this last one because 70 is greater than or equal to 55. So when f is 70, the function value will be a 6. And lastly, let's solve for f of 1, and it'll put all the pieces together. It's going to be exciting, you guys. I'm super excited. So when x is 1, the only one that works is this first one, because if I put in 1 for x, so if I kind of treated like the x was a 1, that would be a true statement. 1 is in between 0 and 13. So when x is 1, the function value will be 5. So bam, that one's a 5. Alright guys, the next step, we got to put it all together. So let's start with f of 13. f of 13 is a 9. Actually, I'm going to rewrite it so we can kind of see how it all falls into place. Alright, so our f of 13 was a 9. Our f of 70 we said was a 6. So plus 6. And then our f of 1 was a 5. So I'm going to say minus 5. So all I did was replace each of these bad boys right here with what they equaled. F of 13 was a 9. Plus f of 70 was a 6. Minus f of 1 was 5. Alright, so let's just combine our like terms and then we'll be done so with this problem. So let's start here. 9 plus 6 is going to be a 15. And then I'm going to bring down the 5. Alright, and 15 minus 5 will give me a 10. So that means our answer for all of that, f of 13 plus f of 70 minus f of 1 will give us a 10. Voila. That is it, you guys. So don't overthink it. It's not too bad once you get the flow of things. Alright guys, let's go back to our Prezi.